quicker than the texture of space-time can stay aware of it. It'll simply tear. I'm scared by this right now. Our night sky is changing quickly, and in simply a question of many years, if not sooner, it could become completely unrecognizable. Cosmologists worldwide are sounding the alarm. Experts like Neil deGrasse Tyson have recently confirmed the impending explosion of Polaris, and the implications are terrifying. Polaris, known as the North Star, has long been a constant in our night sky, serving as a critical reference point for stargazers, pilots, and astronomers. However, this could soon change, altering our night sky and astronomical measurements forever. We should delve into the significance of this threat and its implications for all of us. Join us as we uncover the story of Polaris as it nears its end. For centuries, Polaris has guided sailors and astronomers alike, holding a revered position as a guiding light. Its steady presence in the night sky has been essential for navigation. Yet, this stability may soon be disrupted. In September 2023, a research paper presented by the esteemed Royal Astronomical Society cast doubt on the fate of this celestial beacon. Polaris is on the brink of exploding, possibly disappearing from the night sky forever. Before we explore the consequences of this discovery, let's understand more about Polaris. Also known as the North Star or Pole Star, Polaris is unique due to its proximity to the celestial North Pole. Positioned directly above Earth's North Pole, it appears almost fixed in the northern sky. Located in the constellation Ursa Minor, or the Little Dipper, Polaris shines as a relatively bright yellow-white supergiant, much larger and more luminous than our Sun. It is not a single star but part of a complex triple star system, with Polaris A and Polaris B forming a binary pair while Polaris B orbits around them. The interactions among these stars generate gravitational forces, shaping their orbits and influencing their behavior. Any disturbances in these interactions can lead to irregular variations in the star's brightness or pulsation patterns. However, the exact mechanisms behind these interactions remain unclear. Polaris is located approximately 323 light-years from Earth, meaning the light we see from it today began its journey more than 3 centuries ago. Therefore, if Polaris were to explode now, we wouldn't observe it for over 300 years. It's even possible that Polaris has already exploded, and we're yet to witness the light from that event. Throughout history, the North Star has held immense cultural, navigational, and symbolic significance. Its stability and fixed position made it an invaluable guide for ancient sailors, leading them across seas and lands. Symbolically, Polaris represented consistency and direction, remaining steadfast amid the ever-changing night sky. For astronomers, Polaris has served as a crucial reference point, aiding in the study of celestial motions and variable stars. As a Cepheid variable star, its periodic changes in brightness have provided valuable insights into stellar properties and the nature of variable stars. This characteristic also played a crucial role in determining cosmic distances and calibrating instruments. These pulsations follow a predictable pattern, making it easy to anticipate its behavior. However, Polaris has recently deviated from this predictable behavior. This anomaly in its pulsation cycle has puzzled astronomers, prompting a closer examination of this celestial phenomenon. Instead of its usual expected pattern, Polaris has begun displaying erratic fluctuations in brightness. Scientists are now raising concerns that the star may be approaching the end of its life. This aligns with behaviors typically observed in stars nearing their demise. The ongoing elongation of Polaris' pulsation period, once stable, can be attributed to interactions within its star system. Astronomers have observed an annual increase in the pulsation duration of 4.5 seconds. While this may seem minor, it holds significant implications. Some astronomers suggest that gravitational interactions between the Polaris stars could be causing these fluctuations in its atmospheric conditions, directly affecting its pulsation patterns. However, others are more alarmed, believing that similarities between Polaris and Betelgeuse suggest the star is on the verge of exploding. The parallels between Polaris behavior and that of Betelgeuse, another massive star in the Orion constellation, are striking. Both stars have exhibited puzzling irregularities in their luminosity, raising concerns about a potential explosion. Stars in their final stages often display such anomalies before reaching the climax of their life cycles. While NASA has expressed heightened concern about Betelgeuse, similar attention has not yet been formally directed toward Polaris. As a Cepheid star approaches the end of its life cycle, it progresses through various stages including the main sequence phase, red giant phase, and ultimately the supernova explosion. Based on Polaris' erratic pulsations, scientists predict it has entered the stages of helium depletion, characteristic of Cepheid stars nearing their end. These anomalies in Polaris behavior align with patterns indicative of Cepheid stars in their twilight stages. However, definitive signs of an imminent supernova remain uncertain. Astronomers are continuously analyzing these irregularities to determine Polaris' fate. If Polaris were to go supernova, it would likely be a spectacular event in our sky, possibly outshining the moon and becoming one of the brightest objects visible for days, weeks, or even months. Its presence could dramatically alter the appearance of familiar constellations, such as the Big Dipper or Ursa Minor, of which Polaris is a part. Rest assured, Earth would likely be completely safe even if Polaris were to explode, given its mass and distance from us. While a Polaris explosion might not be as visually dramatic as Betelgeuse's, it could still be visible to the naked eye for an extended period and overshadow nearby stars. Astronomers and observatories would undoubtedly take notice, sparking widespread interest within the scientific community and among stargazers worldwide. However, the specific visibility and impact on Earth's atmosphere or surroundings would be less significant compared to a closer supernova event. But what about Polaris itself? What would be its fate after a potential supernova explosion? Let's clarify one thing. While massive stars typically end their lives with a supernova, this is likely to be the case for Polaris. When a massive star goes supernova, a colossal explosion occurs within it, marking its final catastrophic moment. At this stage in its life, this interaction includes a total breakdown of the center, setting off a serious shock wave that makes the star detonate viciously. Anyway, Polaris isn't sufficiently huge to go through such a blast. Rather, when Polaris debilitates its atomic fuel, it will shed its external layers and change into a white dwarf. This change won't bring about a supernova but rather a tranquil end as it evolves into a small, very dense stellar remnant. A white dwarf is the leftover of a low or medium-mass star that has depleted its nuclear fuel. It is incredibly dense, probably as massive as the Sun but compressed to the size of Earth. When this happens, we will no longer be able to see its remnants from our planet, similar to how we observe the star today. Looking at the expected effects of Polaris evolution within the context of historical supernova events provides valuable insight into the evolution of stars and their ultimate destinies. Comparing our expectations with confirmed supernovae like SN 1054 or SN 1987A, as well as later events such as SN 2011 Fe or SN 2014 J, provides essential data for understanding the potential consequences of Polaris transformation. SN 1054, for instance, resulted in the formation of the Crab Nebula, a cloud that continues to expand and emit radiation across multiple wavelengths, offering astronomers a rich field for study. Similarly, SN 1987A, observed in the Large Magellanic Cloud, provided insights into nucleosynthesis processes and the dynamics of supernova remnants. Studying phenomena such as nebula formation, the release of cosmic rays, and variations in luminosity can offer insights into Polaris' unique characteristics. The formation of nebulae like the Crab Nebula results from the expulsion of material during the supernova explosion, which interacts with surrounding interstellar gas and dust, enriching it with heavy elements and contributing to the cycle of stellar birth and death. Furthermore, the release of cosmic rays, high-energy particles accelerated by supernova shockwaves, has implications for astrophysical processes and cosmic radiation environments. To make a definitive comparison, scientists analyze differences in mass composition and the velocity of ejected materials between Polaris potential burst and other observed events. This involves studying light curves, spectra, and remnants from these events and extrapolating similar characteristics for Polaris' possible transformation. Assessing whether Polaris transformation could lead to the formation of nebulae or distinct elemental distributions enhances our understanding of its potential outcomes. Another crucial area of research involves evaluating the pulsational variability of stars approaching their final stages, comparing Polaris with observed supernova progenitors. This comparative analysis can help determine similarities or deviations, providing insights into the mechanisms leading to stellar explosions. Pulsational variability in stars nearing the end of their lives may indicate internal instabilities or impending catastrophic events, offering clues to the evolutionary processes preceding supernova explosions. Despite meticulous observations and extensive research, astronomers remain perplexed by the inconsistencies observed in Polaris behavior. Unraveling the unique conditions driving these anomalies holds the key to advancing our understanding of stellar evolution. Understanding the mechanisms responsible for Polaris' irregular pulsations requires interdisciplinary collaboration and the development of advanced theoretical models and observational techniques. The potential loss of Polaris as a critical reference point in the night sky presents significant challenges for astronomical endeavors. Ground-based telescopes and celestial measurements would require recalibration, affecting the accuracy of astronomical assessments. The absence of Polaris could also impact navigation systems and cultural practices that rely on celestial landmarks, highlighting the significance of this stellar event. The enigmatic behavior displayed by Polaris underscores the importance of monitoring stellar phenomena and fostering collaboration to resolve uncertainties surrounding stellar evolution. Polaris has long been our cosmic guidepost, but its eventual fate challenges our understanding of stars and their dramatic transformations. As we continue to observe Polaris' unpredictable behavior, astronomers grapple with the uncertainty of its future. While the idea of a supernova might seem like the most dramatic outcome for a star like Polaris, it's crucial to remember that not all massive stars end their lives this way. For a star to undergo a supernova, it must have sufficient mass. Typically at least 8 times that of the Sun. Polaris, though massive, is not massive enough to meet this threshold, meaning its final stages will likely unfold in a much quieter manner than previously imagined. Instead of exploding in a violent supernova, Polaris is destined to experience a transformation that is far less catastrophic. As it depletes its nuclear fuel, Polaris will shed its outer layers, gradually cool and shrink, ultimately becoming a white dwarf. This is a common fate for stars that aren't massive enough to trigger a supernova. Over time, the white dwarf will continue to fade, and although it will no longer be visible to the naked eye, it will persist as a dense, compact remnant of its former self. However, this process, while not as visually spectacular as a supernova, still holds great scientific significance. The transformation of stars like Polaris into white dwarfs is a fundamental part of the cosmic life cycle. The material ejected by the star during its shedding of outer layers will contribute to the interstellar medium, enriching it with heavy elements that can later be incorporated into new stars, planets, and even life forms. The disappearance of Polaris from the night sky would have profound implications not just for astronomers but for those who have relied on it for centuries for navigation. The North Star's fixed position has made it an essential point of reference, especially in the Northern Hemisphere, where it has guided explorers, sailors, and travelers for generations. For many, its disappearance would be a symbolic loss of an anchor in the sky. However, astronomers and navigators have adapted to other methods of celestial navigation, and while the absence of Polaris would be a notable change, humanity would adjust. In the meantime, astronomers will continue to monitor the behavior of Polaris and similar stars. Advances in technology and the development of more precise instruments mean that we are better equipped than ever to track the subtle changes in these stars and predict their future behavior. The eventual fading of Polaris will serve as a reminder of the dynamic, ever-changing nature of the universe. Even the stars we once believed to be fixed and eternal have their own life cycles, periods of stability followed by dramatic transformations. The ongoing study of stars like Polaris also provides crucial insights into the broader mechanisms of stellar evolution. Understanding the processes that lead to the formation of white dwarfs, supernovae, and other stellar remnants allows us to better comprehend the future of our own Sunday. While the Sun will follow a different path, eventually becoming a red giant before shedding its outer layers and leaving behind a white dwarf, Studying stars like Polaris helps us piece together the cosmic puzzle. On a cosmic scale, the demise of Polaris will likely be a relatively quiet event compared to the explosion of a supernova. Yet, for astronomers, it will mark a significant shift in our understanding of the life cycles of stars and the intricate forces that govern their behavior. It will mark the end of an era for astronomers who have long relied on Polaris as a constant presence in the night sky.